So let's take a quick look at the clustering operation which can be performed using SciPy. For that, I would import stuff from scipy.cluster.vq. So basically, this is where all your clustering methods are stored. VQ is a sub package in the cluster package which has your clustering functionality. I would import k-means, as this is the clustering algorithms used. VQ, which stands for vector quantization, which would be used in prediction, and whiten. This is a method which is used for a normalization purpose. Okay, so it divides your array by the standard deviation. Also, let's start by creating an array. So let A be the array which we are going to be using. So this is A. It has the points 1, 1, 1, 2, 4, 1, and 4, 2. So there are 4 data points in your array or your matrix. So you must consider each of these as separate data points. So if you have a Cartesian space, so 1, 1 is your first data point, 1, 2 is your second data point, 4, 1 is your third data point, and 4, 2 is your fourth data point. Also, let's okay. So now let's try to whiten this array. So let's store it in B. Let's say whiten of A. So basically, what this does is it computes the standard deviation uh, of the elements and divides them by that. So you can see that if this is, so if the first column is one attribute, it has computed the standard deviation and divided by the standard deviation of that attribute. It has done the same for the other attribute. Now I can perform clustering on this on either of the arrays by using the k-means method. So let's do that. K-means, so if I do it on A, it would be the raw data, but if I do it on B, it would be after whitening. So let's do it on A first. So I pass A and the number of clusters I want. So basically this returns a tuple. In this tuple there is an ND array which is called the code book. So basically the code book tells your cluster centers. So this says that you have 2 clusters. The centroid of the first one is 1, 1.5 and that of the second one is 1, 1.5, and the second term the tuple talks about the error. So now I have computed the cluster centroids. What I would want to do is try to predict this on any data I have. So for this I can use A, or I can create another matrix or another set of data points. I'm not going to create another set of data points. I would show how you can predict on A. For the purpose of prediction, you would use the VQ method. To this, you would pass the matrix containing your data points. So this would be A in our case. And you would pass the code book. Essentially, the code book is the 0th element of K. So you can pass that. And this tells you the distance from, so this tells you the cluster number. So you can see that, so let me print A. So if this is A, you can see that the point 1, 1 is assigned to cluster 0, where cluster 0 is 1, 1.5. And also this array tells the distance. So you can see that it is at a distance of 0.5 from the cluster center. So this is the Euclidean distance. This same, I mean, if you check for the other points, it is true for the other points as well. So this is basically how you can do clustering. You might want to cluster after whitening, so you can do that as well. So instead of passing A, you can pass B with 2 points. So this is B. So these are your new centroids after whitening. And you can also predict. using that. So I would pass b and k1 of 0. So this is your prediction after whitening. So this is how we can do clustering using SciPy. Let me talk quickly about the ndtry function. So this is a special function which can be found in the special package. This function has been used further in the course. So let's just look at how the function can be used. For that, you would have to import the ndtry function from scipy.special. And to this function, you can pass a scalar value or a matrix. So essentially what this function does is that it returns the argument x for which the area under the Gaussian probability function is equal to y. So if you pass a value y to this function, it would return the value x for which the area would be equal to the area under the Gaussian curve would be equal to y. So basically, this is an integration from minus infinity to x, which would yield y. So basically, you can say that it is trying to compute x such that y equal to integral of minus infinity to x, and inside the integral is your Gaussian function or your standard Gaussian function. So let's say 0.4. So this is the value of x at which the complicated integral I talked about would be 0.4. We can also pass in arrays. So let's do that. So this is how you can also pass in arrays. You can use a number of other special functions in the same way. This is how you use your special functions. ndtry was an example. You can also take a look at the other special functions. You can find a link to the special functions in the references page we just saw. So in this page, if you click at special functions, you can see all the special functions which are present. So it is a long list. You have Bessel, you have 0 of Bessel functions. So these are special functions which can be used. So go ahead and use these special functions whenever you need. The ndtry function is used further up in the class, so I have talked about. So this brings an end to the SciPy lesson of this unit. So here we've looked at SciPy and looked at the reference section to SciPy, like the online documentation. So you can go there and check out the various functions SciPy provides. And we have also taken a deeper look at clustering and special functions. So go ahead and take a look and play with SciPy.